Thanks for having me. Yeah. And so, yeah, I work for Buoyant, and I'm here with some colleagues, William, Kirsten, and Stephanie. So if you have any questions about Linkerd or Buoyant, they'll be around afterwards. And I can stick around as well. So let's see. I will tell you a little bit about myself. I'm an engineer at Buoyant. I've been there 3 years now, and before that, I was at Twitter for 5 years, working on the platform team there. And Linkerd was born about a year after Buoyant, the company, was born. So we open sourced it a little over 2 years ago, and have gone through a few iterations and a lot of upgrades and improvements, and we'll talk about them now. So I've been, kind of in my tenure at the company, I've worked on Linkerd 1, and I worked on Linkerd 2, and I've done a lot of other miscellaneous work, pretty much whatever William tells me to do. And I don't give a lot of presentations, so we'll see how this goes, but bear with me. William. All right, so let's see. I thought most of you give a great overview of what a service mesh is, why you would want to use it. So I actually just have one slide, which is sort of what I think about when I think about a service mesh. And really, it's all about communication. That should have been really obvious from the last presentation. So communication is really just a fundamental part of a distributed system or a microservices setup. And if your services can't talk to each other, then nothing will work. And it turns out that communicating is really difficult. So let's see. It makes sense to take, in a distributed environment, to take the communication layer and pull it out and treat it as its own infrastructure component. And so that component is really there to ensure the reliability, security, and visibility of the entire system. And so the how do we actually do that is let that layer manage all runtime communication. So when service A needs to talk to service B, it uses the mesh. And the mesh ensures that it's a reliable, secure, and visible transport. So reliability, this is kind of what was already covered in depth, but a lot of the things that you would need to do to make an RPC are now handled by the service mesh. So service discovery to find the set of addresses that you want to route to, and then load balancing over the set of addresses. And then once you've initiated connections, sort of managing traffic on the connection to make sure that you're not waiting too long on bad requests, or like say circuit breaking, if you want to reroute around a service that's failing, or you want to retry the service. The reliability layer can handle all that for you. Security, so also if you have the service mesh sort of at either end of one connection, then you can do stuff like auto upgrade that connection to use TLS so that all your service communication is secure. And in a meshed environment, you also you can do like client validation because you have the identity of the pods that are calling each other, or the services are calling one another. And visibility, so this was also covered really well in the last presentation. Basically, once you are routing all your traffic through one layer, that layer is exporting uniform stats. So it's much easier to get a picture of how your overall application is performing, rather than say every service implements its own stats collection and those stats are exported in any different format and they're not really correlated. This would give you a visible, uniform, visible picture. And can also do cool stuff with like tracing and that kind of thing. Okay, so yeah, I think I'm going to talk about sort of past, present, and future with regards to the service mesh, kind of where we're at and where we're going. And I'm going to start really, really long ago. I didn't do any of these slide animations, by the way. That somebody gave them to me. But this is the LAMP stack. You may remember it. So sort of in this world, you have an application server, and the application would contain your whole application. So basically any request that arrived from the internet through maybe Apache would hit an application server, and the application server had everything it needed to know to serve the request, except for maybe the data, which would live in the database. But that, for many reasons, was sort of untenable. One is that applications got more complicated, and Also, if you introduced a bug in the application, that just takes down the entire site because you've cascaded the only thing that's capable of serving your request. So let's see. Then kind of moved in this world of fat clients. So we started to break things up into microservices, and the services will all talk to each other. And in that architecture, especially if the services are all written in the same language, it can be really tempting to introduce a library that handles the service mesh. The communication there, so service discovery, load balancing, retries, timeouts, stuff like that. A really good example of this that I'm familiar with is Finagle from Twitter. So Finagle is an RPC library. It's written in Scala. And if you're running a JVM app, you can use Finagle to route your request, and you would just import that code into your service itself, and then it would run there. But the problem is once you move into a larger architecture and you have multiple different languages in production and that kind of thing, then you're re-implementing a library in every language. Like that. So this is sort of where the service mesh comes from. So we kind of take that library code, and this is literally what we did with Linkerd initially, was we took the Finagle code that was used by all the services internally at Twitter and pulled them out and put that code into a proxy, so that now you don't need every service to have a library that tells it how to route requests. Every service just knows that there's a local process that it can talk to, and then that process will send the requests, and it will be resilient. And Finagle has been totally battle tested over, years and years at Twitter in all sorts of insane failure scenarios. So there's a lot of edge cases sometimes, and Finagle has encountered most of them. So its load balancing algorithms are really finely tuned for high load and that kind of thing. So you can kind of get the benefit of Finagle without having to write every service in the JVM if you switch to kind of the service mesh model. So this was kind of a fundamentally different way to structure your platform. And it's exactly what WePay is doing now, is they've introduced Linkerd, and it really is has changed the platform, and it kind of dictates how metrics are collected, how requests are routed, and everything else. So it's a very similar graphic to this in the last slide, but basically you would roll Linkerd out much like a utility, like in the same way that you would do log collection or something like that. It would be sort of ubiquitous and available to all the services in your cluster. And when service A needs to talk to service B, it talks to its node local Linkerd, and then Linkerd finds where it thinks it should send the request, and then it sends the request. And so this is great. And in fact, this works in a wide variety of platforms. So it works in Kubernetes, but it also works in DCOS, or it works on bare metal hardware with a console backing store for service discovery. I mean, basically, you can run Linkerd in like a million different configurations. But it kind of requires a decision from the platform team to adopt it, right? Because it's sort of at this like fundamental level where you really need it to either be everywhere or kind of, you're not going to get to it. And so it's Moses' job, and he rolls it out, and we're really happy for that. But so in thinking about the service mesh, though, we really wanted to adopt a strategy that would allow for a little more incremental rollout. And that's what we've been thinking about with Linkerd too. So not every service has to buy in the mesh. And so Kubernetes has this pod model, right? So in Kubernetes, when you deploy your service, it will deploy that in a series of pods. And pods is really just like a cluster of containers. And so in the pod world, you could include a Linkerd container in the pod, and that can mediate communication. And that's like at a much more granular level than, say, needing it on every single node in the Kubernetes cluster. And so this is sort of like more like the service sidecar model. So this is kind of where we're going with Linkerd 2. So now, rather than sort of these big fat routers that you have everywhere, like individual pods can elect to join the service mesh, and they can then add a proxy to their deployment, and we call that the data plane. And then proxies are controlled by a control plane. And so the control plane is like Named in the Linkerd 1 world. It's running in a different namespace usually. It is highly available, and it handles things like metrics collection and diagnostics. And you can also pull up the Linkerd 2 web UI, which I'll demo in a sec. But so you sort of get a lot of things happening in the control plane, and then a very straightforward gRPC API between the proxies and the control plane. And so proxies the control plane is pulling data from the proxies, and it's also pushing routing information and policy out to all of the proxies. So I want to talk about the control plane just in a little more depth. Linkerd 2 also hit GA yesterday, by the way. So we've been kind of working at it for a while, and I think we're really happy to roll it out and call it official. And so the control plane is a little simpler. It has a couple pods, and the pods do different things. So let's see. Down here in the data plane, you just have this Linkerd proxy process. So one of the things that is happening is that Prometheus is scraping metrics from all of the Linkerd proxy processes. And that happens with 0 configurations. Basically, when you add the proxy to your container, or to your pod, it is set up with a series of annotations that lets Prometheus find it automatically and then scrape its data. And then Linkerd is also routing requests. And as it is being asked to route a request to a new destination, it's talking to the proxy API, which talks to the destination servers, which really handles service discovery. So this is kind of where the service discovery component comes from. And then we have a lot of visibility into the cluster as well. And that's sort of one of the really cool features with Linkerd 2. So there's a web UI, so you can, and I'll show you, you can bring up some data about the cluster. But the public API also is accessible from a CLI. And you can do really interesting things like ask any given proxy for a sampling of requests that it's serving. So we call that tap. So basically, in the web UI, you can start looking for certain types of requests. And then the control plane will reach out to the data plane and say, like, hey, if you see requests that match this filter pattern, send them back to me, because somebody is interested in finding out what those requests look like. Either they're taking too long, or they're different status code, that kind of thing. So yeah, so really the division between control plane and data plane gives us a ton of flexibility to build out these features. And that's kind of how we made the move to this model. Let's see. Okay, so now I'm going to give a demo of the Linkerd 2 world. I wanted to leave some time because it'll take a little while. If you want to follow along on your laptop, you can get the Linkerd CLI by running this curl command and piping to bash, if you trust me. And yeah. And so yeah, give me a sec. I'll pull up a terminal and we'll kind of go from there. We're going to go through installing the control plane and then installing an application and sort of getting some visibility into how the application is performing. Are there any questions though before we move on to the demo? Excuse me, I'm going to sit down for this. Okay. So let's see. So on the command line here, let me see if I do that. Okay. Let's see. So I already have Linkerd 2 installed. So version client. So I've already run that curl command and I've gotten my Linkerd control plane. And so I'm going to go ahead and install the control plane now. So when I run this Linkerd install command, that's going to spit out some YAML. And I can pipe that YAML to kubectl, and it will set up all the components in the cluster that I need. I'm going to do this first before I get to the demo application, just because it takes a little while to spin up. So I can just go ahead and pipe that to kubectl apply. So this will sort of define all the pods that we covered in the thing. And then I can just run the Linkerd dashboard command to bring up the dashboard. And what this is going to do is going to wait in the background for Linkerd to become available. All right, so switching to a different window. So now if I look at my pods in my default namespace, I have MySQL running, but I don't have anything else. So I'm going to go ahead and install a books application that I wrote. So we'll do kubectl apply -f book app.yaml. And this is a couple deployments. So this is a toy microservice type thing. And basically we have 3 different deployments. One is a web deployment that talks to a books deployment and an authors deployment. And I can show you what that looks like in my browser here. Give it a second, it will come up. Yeah, there we go. Cool. I have all sorts of stuff on my screen. Get rid of it. Okay, so I'm not really a web developer, but I use Bootstrap and I made this website. And basically, whereas you may have in the past made an app like this to catalog your books as like a standalone app, this is really 3 applications and they're working together. And so you can kind of click around and you can see that there's different authors and books and you can add them and edit them. So I'm going to go ahead and add a few books. Let's see. So Michael Chabon, popular author, he wrote Mysteries of Pittsburgh. Oh, yeah, I missed the H. And I got an internal server error. So let me try to resubmit that, see if it works. No. No. Maybe I dropped the H. Oh, there we go. It worked. So it just takes a little time, but clearly something is not working with this application, right? So now if I were just running this in Kubernetes, probably the next thing I would do is like go to the command line or go to the Kubernetes UI and see what's going on with the application. Like clearly something is not right. So let me go ahead and do that. So I'll run kubectl proxy here. And then Kubernetes actually has a really nice dashboard that shows me a lot of information about all of the resources that I just created in Kubernetes when I ran my apply command. So I got some deployments. So here's my MySQL, authors, books, web. I also have a traffic generator running in the background. These are all the pods that were created to like serve my app. Couple, replicate sets, services, but really everything in this UI tells me that everything is healthy, right? Like the main takeaway here is that my pods are up and running, but it doesn't give me any visibility about how they are actually performing from a correctness standpoint. And so in order to do that, you actually need to use something like Linkerd, because Linkerd is a protocol-aware router, and so it can say, based on the protocol that it's routing, like this is a failure, this is a success, that kind of thing. Whereas Kubernetes really just sees TCP traffic and objects that are created. So, okay, so let's go ahead and look at the Linkerd dashboard, which loaded. And it looks like this. So we see all our Kubernetes namespaces. In the Linkerd namespace, Linkerd itself is a Linkerd-enabled deployment. The control plane is injected with data plane proxy. So you can inspect the Linkerd control plane in the same way you would any of your other services. And so if I just look at like the Linkerd web service here, I start to see information about which of the pods in my control plane namespace are talking to each other, what request volume they're sending, how they're performing, and I can even see like individual requests, right? So like loading the web UI processes a lot of metrics, so it makes sense that the metrics requests here are at the top, So anyway, but I think it's going to be more useful if we look at the demo application itself. So the next thing to do is to add the data plane to the service that we want to debug. So let me go ahead and do that. So I'll shut down the proxy here. Right, so now there's a command similar to the Linkerd install command. There's a Linkerd inject command. Inject takes the YAML file of a service that you want to inject with the Linkerd proxies, and it modifies it to add Linkerd's, the Linkerd proxy, the data plane. So if I run Linkerd inject, same app. So this is the one that I ran apply on earlier. Can everyone see that? Okay. And I pipe it like this. So it's still YAML, but in the YAML, there's sort of all these additional fields that, including an init container, that will modify the pods that we want to deploy to include the Linkerd proxy. The init container uses IP tables to rewrite the routing rules on the pod so that any inbound request to the pod or outbound request from the pod first passes through the Linkerd proxy. So there should be no application changes here. In fact, I'm using, oh, did I draw that? I'm using the same Docker images and everything else. I just have added into my pod spec the additional like routing and stuff. So, okay. So let me go ahead and apply that. Cool, so it's telling me that from that config file, 4 of my deployments were supported. And then it has gone ahead and redoing. So if I run kubectl get pods now, you'll see that some of the previously uninjected pods are shutting down and the new pods are spinning up. And this is happening based on your deployment constraints specified in your Kubernetes config file. So it will do a slow roll of your deployment. So you can sort of incrementally add the proxy to all of your services as you go. And we can run a Linkerd check -- proxy to make sure that the proxies have come up. Linkerd check proxy to make sure that the proxies have come up. And so this is telling us that a pod is running, but the proxy container isn't ready yet. So we have readiness checks built in. So Kubernetes will wait to send it traffic. And then now the checks have passed, and we should be good to go. So let's go back to the web UI here to the overview. And so now we can see that the default namespace is injected. And right away, we start to get additional stats about the traffic that's passing through the application. So I didn't inject MySQL, so it's sort of uninjected, and the traffic generator is only generating outbound traffic, not receiving inbound. But for any pod that's receiving inbound traffic, those are the stats that we're displaying in this view. And you kind of get all the, like the big 3 in terms of service health metrics. You get success rate overall, and a request rate, so the number of requests that the service is serving, and then some latency numbers to tell you how fast or slow it is. We also tell you if it's TLS, because I didn't install it this way, but you can enable TLS automatically for all your installs. I probably should have done that. In which case, the TLS column would tell us that all the traffic is also TLS. Cool, but clearly things are unhealthy, right? Like success rate of 77%, not great. So now at this point, we can use the web UI to dig in to figure out what is not working correctly. So I'll start by looking at the web service, which is really the front end. And yeah, you can see that some of these endpoints are failing pretty readily, like this books.json. And this actually tells you, so this is traffic from the web service to the books service. These are the web pods, these are the books pods, and their IPs. And that route has been called 41 times, and its overall success rate is about 50%. So that is not great. You can also sort of see it in a different layout down here, which is inbound and outbound. So, and then this maps to what we're seeing in the graph. But one thing of note in the graph is that external traffic is failing at a rate of 25%, and the web service is failing, obviously, at about a rate of 25%. But all the failures are coming from the Books app, and none of the failures are coming from the Authors app. So at that point, I'll probably click into the Books app and say, okay, so what's going on here? And in this view, you can see that the Books app is actually also calling the Authors app. So when the web service calls the Authors app, that request is 100% successful. When the web service calls the Books app and the Books app calls the Authors app, that request is failing. So at this point, knowing a little bit about my application helps, because I can say, okay, so in what circumstances does the Authors app call the Books, or sorry, does the Books app call the Authors app? And so this happens when you create a new book, it has to validate that the author exists. So let's go ahead and go to the Authors service. And we can kind of look at the different types of calls that are happening, and we can see right away that one of these is failing quite a bit. So I'm just going to go ahead and click on it. And that takes me to this page. Let me clear this out. And now we can, this is the feature where we can actually tap into the proxies themselves and say, like, show me all the requests between these two services. So when the Books app calls the Authors app, like, what does that traffic look like? And so if I just stop this, we can look down here and we can see that almost all of these are head, or in fact, all of them are head requests to the author service. So this is really the on book create, does the author exist call. And that looks like that's failing about 50% of the time. And you can see that by the 503s here. And you can actually expand the rows, get a little more information. So it's a fast request. This one only took 5 milliseconds, but it resulted in a 503. And Anyway, so at this point, like, I would probably go talk to the owner of the author service and say, like, what are you all doing? And so let's go back here and look at the author service again. And then, you know, it turns out I'm the owner of the author service. So I can just look at my book config here. And there's my books deployment. Here's my authors deployment. Oh, it turns out I deployed it with a failure rate of 50%. That was not really great of me. So I will just change it to 0. And then I can run my same Linkerd inject. Nope. Bootstrap. kubectl apply-f. There we go. And now we should be able to do another rolling update of the service, and without an interruption in traffic, we should see the overall success rate improve. But it takes a little while because metrics are over a time window. I think that the window on the web UI is about a minute. So I just use that minute to also show you some CLI features that you can use. So if you don't like using the UI to debug, the CLI is a great place to work as well. So I could run like a Linkerd stat deploy and see output that is very similar to what we saw in the web UI. And in fact, if I run Linkerd stat deploy -t 10 minutes, this is the success rate over the last 10 minutes. It's sampling stats from Prometheus. And if I shrink this down to like 20 seconds, we're back to 100% success rate. So the snapshot of metrics from the last 20 seconds, it's like I can tell that things have recovered. And another way to do that is you can also tap. You can use Linkerd to tap directly from the command line too. So I can run Linkerd tap deploy / which one do we fix? Authors. And I start to get all this information right away. And this is really just sort of raw request data as they transit through the proxies. And I could search this or whatever and figure out that the status for all the rows is now 200 or 204 and that kind of thing. And the other command that we have here is a Linkerd top command. Linkerd top deploy, which will show us, this one is a little noisy, but it gives us sort of like a Unix top style report of like how the things are performing. This is a brand new feature in the GA, so I think we need to work on the padding for the columns. But yeah, here, let's see. There we go. Yeah, it must be a fixed list. Okay. But yeah, you can start to see that. And so I think we're really going to enhance this so you can do path filtering and that kind of thing. Cool. And then if we come back here, we're back to 100% green because we fixed the problem that was in the app to begin with, which I introduced on purpose in order to give a demo. Anyway, so that's that for the demo. Like I said, you can get the Linkerd CLI right away and start playing around with this stuff. Since the control plane itself is an injected application, like there's some value in just running the control plane and poking around the UI. You can even tap the control plane and it will show you the tap requests that you're sending to all the proxies, stuff like that. So let's see. So quick recap, we installed the application. It was broken in some way. We couldn't tell why it was broken, but by adding the control plane and then adding the application to the data plane, we were able to dig in really deeply and figure out the source of all the failures. And then we were able to correct the failures and verify that it all worked afterwards. And we didn't have to stop any of the live traffic or anything like that. Okay, so that is it for my presentation. These are just additional links. There's lots of documentation up on linkerd.io that you can find the code on GitHub because it's all open source. We have a Slack channel. It's very active if you need any help. You can install it. I have some contact information, and we brought some Linkerd t-shirts in there on the table over there. If folks want t-shirts. So, and now maybe I'll bring Mosin back up and we'll do Q&A. Does that work? Cool.
Hello. How about quorum or things like disconnection or split brain on the services? How do you reconcile those things?
So you mean?
Yeah.
Sorry.
Half of the services are, you have a split brain configuration in your services, so half of them say one thing to the service discovery, half of them say another thing to the service discovery. How that works in the Linkerd.
So Linkerd doesn't manage its own service discovery. It relies on service discovery from a backend. So in Kubernetes, it uses the Kubernetes API. So in the Kubernetes world, you would probably publish a service that would have a selector across all your pods. And the Kubernetes API is the source of truth for routing. So Linkerd is not maintaining any additional service discovery state. So if the Kubernetes service discovery information has gotten out of sync, that would be a problem in any setup. In the daemon set world, it's sort of the same way. The named has a pluggable service discovery backend, and it doesn't have internal state there. Do you have anything else to add?
Yeah, I was going to say, there's cases where you might run into, the API, the discovery backend being behind what Kubernetes is saying, but that's normally it's either there's a network problem or something going on that between those two communications.
Yeah, but there are Linkerd will help with sort of partial failures, right? If the app just becomes totally unavailable, or if the address set is actually not correct, right, and only half the addresses are available, Linkerd has mechanisms for kicking the bad addresses out of the pool, so it won't actually take down your site. Load balancing will basically account for missing instances if that's happening. Yeah.
I had a question.
Okay.
So in Linkerd 2, you showed all those great configurations coming in when you did Linkerd Inject.
Mm-hmm.
Are those shipped with every version of Linkerd 2, or how are those distributed?
Right. So the CLI is versioned, and whenever we release a new release, we will publish new version of the CLI, and you can upgrade at that point. But that won't upgrade the control plane or the data plane by default. You would have to reapply those configs, and they'll pick up new versions. So yeah, the YAML itself will kind of change as you go, but you would have to re-inject your services to pick up the new one.
In your user interface that you were showing a while back, I saw some Grafana links as well.
Yes.
So how is that integration, and is that hosted on your Kubernetes or external to your Kubernetes? Just curious.
Yeah, so I actually should have clicked on those. So Linkerd, we have the web UI, but we also have a full series of time series dashboards built in Grafana that are pre-configured to work with the data. And they use templating, so they should work for any injected service. So I actually think I can probably just show you real quick what that looks like. So if we're here in the author service, and I want to see sort of a dashboard for the books deployment.
So you just put the Grafana URL and it
loads
those values.
So there's an instance of Grafana running in the control plane, so that it's one of the pods, and it's already configured to talk to the control plane Grafana.
Got it.
It's very similar to Linkerd Biz for Biz1. I mean, that's where we got the idea, or for Linkerd 1. But yeah, it says information about the book service and its upstreams and downstreams and everything else. And this would be a place that you could come for more in-depth debugging, especially because of the time series nature of the data.
Also, I had another follow-up question, not related to this, but for the backends of Named, what has your what have your customers been using primarily? Is it Zookeeper or Console? Just curious, what's a majority split from your customer base?
Well, do you want to talk about what WePay is using?
Yeah, so we're using Zookeeper for the storage part. And it's mostly, I think at this point we only have Kubernetes proxies pumping the discovery. That's pretty much the setup.
Yeah, and you can configure with to also read its service discovery information from console, or If you're on DCOS, it could read from the scheduler itself, and same thing on Kubernetes. So it'll read directly from the Kubernetes API if you're routing exclusively within Kubernetes. But yeah, Consul and Zookeeper, I think, are more generic. Yeah. I tend to think of Linkerd 1 as sort of a Swiss Army knife. It can connect to like basically everything. And with Linkerd 2, like it's not meant to subsume all of those things because like it's really much more finely tuned to somebody that's like only on Kubernetes in kind of this multi-service owner model. Yeah.
In your demo, you also pointed about inter-service communication, and you showed a graph where it's not a graph; it's a block diagram of one service talking to making an API call to the other, and that translating to another service. So that was pretty cool. But do you have any implementations where you can kind of detect circular dependencies in our microservice communications and possibly show us that data, so just to avoid loops? And
yeah, have you all set up any of the tracing stuff?
Not sure.
So it sounds like one of the use. Well, so we did here. Let me just show you real quick. If I go back here, if I look at my namespace, like we are able. We're able to draw some graphs. That's not the prettiest graph. They kind of tell you which services are talking to which other services, just based exclusively on their traffic data. If you wanted to get a lot more information here, you could add tracing to your system, which is really just a series of annotations that attach to requests as they propagate through the system. Linkerd 1 does that really well. Linkerd 2 doesn't have tracing yet. One of the problems with tracing is that the traces break unless the applications are also participating in the tracing. So like one of the design goals for Linkerd 2 was like as minimal impact on your own like application development as possible, and tracing kind of breaks that model.
Yeah, so the reason why we kind of opted out in the beginning for tracing was the sampling rate had to be low for everything to perform at a good level.
Yeah, that's totally right. And when the sampling is too low, you miss the request that you would really be most interested in.
So what does this use for tracing? It still uses?
So this is based just on the data from Prometheus, because like now that we have source and destination in Prometheus, we can like work backwards from that to build the graph. And adding like a fully fledged tracing system is definitely on the roadmap, but for the moment we can kind of get by with just service A to service B, service B to service C.
Any other questions? All right.
Okay,
I think that's it. Thanks, guys. We'll be in the back if you have any more questions. Thank you.
Yeah, thanks for coming.